So let's just dive right into this, okay? May 9th. If you glance at a calendar, it probably just seems like, an ordinary, unremarkable day passing you by in the middle of spring. But if you look a little closer at the history books, it is arguably one of the most magical, golden dates in the entire history of mathematics. And I'm going to show you exactly why.
Because on this one single date, across wildly different centuries and stretching across all these different countries, brilliant minds were either born or passed away, and they left behind discoveries that literally built the modern world we live in today. So today's explainer is kind of like a time-jumping detective story. We're going to track 10 distinct geniuses, all magically connected to this single date, and uncover how their completely abstract ideas became the technology that you use every single day. Let's meet them.
To kick things off, let's just look at the physical spaces we inhabit. Have you ever actually wondered how architects build massive, towering 3D skyscrapers using nothing but flat 2D paper blueprints? Or, if we're thinking digitally, how those incredibly rich, immersive 3D video game worlds you explore start out completely flat, existing as literally just lines of code on a two-dimensional screen?
Well, the answer to that little mystery takes us all the way back to May 9th, 1746, with the birth of a brilliant guy named Gaspard Monge. See, Monge invented something called descriptive geometry. Think of it like taking a complex 3D shape, like a solid cube or a pyramid, and shining a super bright light on it so it casts flat shadows from different angles. By doing this, he figured out the exact mathematical rules for flattening three-dimensional objects right onto two-dimensional paper.
This was an absolute game changer. Because of his 18th century breakthrough, engineers finally gained the power to accurately translate our physical 3D reality into 2D plans and vice versa. It's the direct foundation for modern computer graphics. So every single 3D video game world you explore, every digital environment you navigate, secretly starts with this flat math.
All right, still anchored to May 9th, we're going to jump forward in time to the years 1936 and 1965. We're bridging the gap from the 1700s to two modern mathematicians who completely revolutionized how our computers understand these shapes and spaces on a much, much deeper level.
Meet Alexander Kirillov and Karen Smith. Kirillov, who was born on May 9, 1936, mastered representation theory, which is basically the underlying math of symmetry and how objects physically transform. Fast forward to May 9, 1965, and we get Karen Smith, an absolute master of algebraic curves. Now, why does this actually matter to you and me? Well, because their combined mastery of algebra helps our computers take flat, raw numbers and process them into the highly complex, realistic 3D spaces we interact with today.
So the really crucial takeaway here is that algebra isn't just a bunch of random letters and numbers designed to torture you on a classroom chalkboard. It is the invisible scaffolding of our physical and digital reality. The hidden shapes of the universe are, quite literally, built on algebra.
One day, so many incredible stories. Let's make our next leap, zooming directly into the 21st century, to look at the year 2004. We've talked about shapes and spaces, but now let's talk about something you probably experience every single day without even realizing how insanely complex it is.
Here's a question that affects almost all of us. Why does your favorite Spotify playlist sound perfectly clear, even when you're stuck on a bumpy train with a notoriously slow internet connection? Like, how exactly do we stream incredible, high-definition digital sound all the way across the world without it just getting completely ruined by static and interference?
The answer traces back to May 9, 2004, which is the day we lost a mathematician named Anatoli Georgievich Vitushkin. Now, Vitushkin achieved something truly monumental. He figured out how to code signals with what's called a finite spectrum. To put it simply, imagine trying to send a highly delicate glass sculpture through the mail. You absolutely need the right packaging to stop it from breaking, right? Well, Vitushkin wrote the complex analysis that acts as that exact protective packaging, shielding digital sound from static and noise and compressing that audio so it travels perfectly straight to your phone.
I really want you to think about that the next time you pop your headphones in or turn up the volume in your car. Every song you have ever heard on a digital device is secretly made of math. Vitushkin's brilliant high-level signal processing is literally music to our ears.
Okay, let's pivot. Let's see how this very same date impacts completely different fields of human achievement. We're going to jump back and forth across our timeline right now, stopping at 1808, 1876, and 1950 to meet three incredibly unique geniuses who mastered the physics of motion.
Have you ever looked up and wondered how massive commercial airplanes fly so perfectly across the sky? Or, on the flip side, how high-speed internet data travels seamlessly through incredibly long fiber optic cables buried deep down under the ocean? Flight and global Wi-Fi seem like totally, completely unrelated concepts, don't they?
Well, the answer actually connects three brilliant minds all tied to May 9th. First up, John Scott Russell, born in 1808. He discovered solitary waves, or solitons, which is essentially a wave that remarkably just keeps its shape as it travels over really long distances. That exact mathematical principle powers today's global fiber optic networks. Next, you have Gilbert Bliss, born in 1876. He developed the incredibly complex math required for predicting the exact trajectories of moving objects. And finally, Esteban Terradas, who died in 1950, used deep mathematics to basically push the boundaries of modern aerospace engineering and flight design.
When you put their collective work together, it leads to this amazing realization. The math that guides an airplane safely to its destination is fundamentally related to the math that guides the internet through an underwater cable. Mastering the mathematics of motion and waves applies equally to physical travel and invisible digital data. Mind-blowing, right?
All right, still on May 9th, we're now going to jump to the year 1932. And as we do, we're shifting our perspective dramatically. We are moving away from the massive global scale of commercial airplanes and ocean cables, all the way down to the microscopic, invisible scale.
Here's our next big mystery, and it's a really fascinating one. How do we actually know what a tiny atom looks like if it is far too small for human eyes to ever even see? Like, how do scientists map out the invisible chemistry that literally makes up our universe?
The answer brings us to May 9, 1932, the day the brilliant Swedish mathematician Thomas Hakon Grönwall passed away. Grönwall applied insanely complex math to the field of physical chemistry. He successfully used mathematical equations to solve the wave mechanics of hydrogen and helium atoms. So he was essentially using math to draw a highly accurate picture of the invisible atomic forces that hold all of reality together.
This brings us to just a beautiful realization. The invisible building blocks of the universe aren't drawn with a pencil or photographed with a camera. They're drawn with equations. Mathematics acts as our absolute ultimate microscope, allowing us to see the unseen. We've crossed centuries of groundbreaking discoveries, exploring everything from 3D geometry to atomic structures. But we have one final, crucial bridge to cross today. Still on May 9th, we're looking at the years 1931 and 2021 to meet the people who actually teach us how to think about all this complex math. Because at the end of the day, the ultimate question is, how do we actually learn to solve the impossible problems of tomorrow? How do ordinary human beings like you and me actually absorb, understand, and utilize these incredible world-altering mathematical discoveries?
The answer goes back to Geoffrey Howson, born May 9, 1931, and Marion Walter, who died exactly 90 years later on May 9, 2021. Howson dedicated his life to something called the School Mathematics Project, figuring out how to successfully structure math curricula to teach millions of students. And Marion Walter, she taught what she called the art of problem posing. She basically showed us that in math, and honestly in life, we shouldn't just act like calculators trying to find the answers. We have to creatively ask the right questions first, challenging the very boundaries of what we even know.
Every single person we met today, across completely different centuries, working in totally different countries, and studying entirely different fields, all essentially asked the exact same fundamental question. What is the pattern hiding inside the chaos?
And because they ask that exact question, our world today has accurate GPS, flawless music streaming, a massive global internet connected by deep-sea cables, and incredibly immersive 3D graphics. 10 brilliant minds, one date, infinite possibilities. It just goes to show that a single day can genuinely change the course of human history. So, armed with this knowledge, what will you discover next? Keep asking questions, keep looking for those patterns.